Looking at the second example, an Inuit pulls a sled from rest. The sled and luggage have a total mass of 100 or 800 kilograms. The Inuit pulls it by means of a horizontal, light, inextensible rope. There is no friction and the tension on the rope is 100 newtons of magnitude. Now, there's a lot of information in there, especially when you're told that it's pulled by a horizontal, light, inextensible rope. That is superfluous information for this question, but for other questions it could be, because if the rope gives, the tension will change, etc., etc. But we're told it's inextensible, so there's no elasticity in it, so that means the 100 newtons of magnitude stays there. So what we know is that we have an 800 kilogram, okay, an 800 kilogram mass that is being pulled by a force of 100 newtons. That's the information we have. We're ignoring friction. There is no friction, and there's no, in this case, there's no air resistance either. So we have to find the acceleration. So finding the acceleration, we know that force is equal to mass times the acceleration. So that's our force, which is 100 newtons, is equal to 800 newtons times the acceleration. Divide both sides by 800. And we get 1 over 8 meters per second squared is equal to our acceleration. Done and dusted. Then we have to find the distance covered in the first 10 seconds of motion. So for this, we go back to our formula that we learned ages ago, the one that is S is equal to UT plus a half AT squared. So just quickly to remember, S is distance, U is the initial velocity, T is the time, A is the acceleration. Now, we're going to say that S is equal to our initial velocity. We know he pulls it from rest, so that means our initial velocity is 0. Then we have our T plus a half times our acceleration, which is 1 over 8, and our T, which is 10 squared. And I'm just going to get that and do that on my calculator. And that's going to be 0 times 10 plus a half times 1 over 8 times 10 squared, and that will give me 6.25 in its distance, so it's meters.